Hello and welcome to ISA's Gear Inspection video. I am Alex Julius. I'm an ISA board certified master arborist, certified tree worker climber specialist, and tree risk assessment qualified.
And I'm Warren Williams, an ISA certified arborist, a certified tree worker climber specialist, and I'm also the chair of the rules committee for the ISA International Tree Climbing Competition.
Let's start off by thanking our sponsors. Thank you to ISA for facilitating this video and to Husqvarna for sponsoring it. This is going to be a high-level look at gear inspection. We'll be looking at the importance of inspecting your gear.
And we have to remember when we're out actually working, we need to follow all of our local, national, regional rules and regulations. And we have to use all this gear in alignment with all of our manufacturer recommendations.
Remember that this training does not replace a more thorough training with your employer.
Let's start with our gear inspection and overall equipment overview. First thing we want to do is we're going to match our personal protective equipment to whatever situation and job that we're doing out in the field. Then we want to make sure that all of our equipment is actually for use in arboriculture. We want to make sure whether it's soft good, hard good, or any of the other tools that we're using in the field are for the arborist industry. The reason being, arborist industry tools are a little tougher and a little more specific than the other realms that are out there in the at-work height industries. Then we want to ask ourselves, the tools that I'm using, do they meet the standards in the area that I'm actually using them? Here in the US, OSHA and ANSI are the ruling standards that we want to consider, but we also might have state or local standards that we have to be cognizant of, and or for whatever company we happen to be working for at that time. These standards are different over in Europe. You'll have CE standards. We want to make sure we conform to those or anything else that might be in that particular part of the world where you're at. The other thing is when we pick our equipment for use, we want to make sure that we're using it according to the manufacturer's specifications. It's nice to always have that owner's manual handy when we want to make sure we're using the tool correctly. And then when we're having one tool hooked onto another, hardware to software, we want to make sure that the compatibility is going to make sure that everything is working as it's intended, as it was manufactured to do.
So let's talk about the overall inspection process. When we're doing our inspections, we want to be in a clean, well-lit space that we can actually look at the equipment. We shouldn't be in the noisy workplace where there are all of the distractions. We could miss something crucial. Once we've established where it is that we're doing our inspection, let's talk about the fact that there are 3 different kinds of inspections. So we could be doing our pre-climb inspection. So before we start every day, we want to give a kind of rough overview of our equipment that we are going to be using. So this is sort of a quick glance. We might do a couple function tests, give a little feel to our ropes, make sure nothing from the previous day happened, make sure that everything was stored properly before we start our work. But this is a pretty quick inspection, and you're probably doing that to your own equipment. But then the next inspection is going to be a more thorough one, and that's what we're going to be covering in this video. So this is a documented, likely monthly, quarterly, whatever your policy is at your company, but let's stick with monthly. This is going to be a very thorough inspection. We're going to be doing function tests, and you need to have a competent person doing it. Part of that too, with having a competent person, having somebody other than yourself inspecting your own equipment, you're more likely to pull something out of service if you haven't paid for it. If you are accounting for someone else's life, you're probably going to say, do you know what, Warren? Let's not use that anymore. Let's get you something else. Versus if I have my own equipment and I say, oh, but I paid $200 for that. Well, maybe I want to keep it a little bit longer. No. So we're going to be inspecting someone else's equipment. It is going to be a competent person, and this is going to be very thorough. The third type of inspection we're going to do is a post-incident. So this could be if something catastrophic happens, such as unfortunate accident in an office, that is going to require an inspection of all of the equipment that was involved in that incident. It could also be as simple as a carabiner that has slipped from someone's hands and landed on a sidewalk. We want to make sure that we give that a thorough inspection before we put it back into play. When we do our inspection, we want to use all of our senses. We're going to be looking at everything, We're going to touch it all. We're going to potentially smell it. We're going to be listening. We're using all of our senses to really get in tune with that equipment and make sure it's ready. We also want to know what that equipment looks like new. As long as we know what it looks like new, then we can do a thorough inspection to make sure that no big changes have occurred that could change the function of the equipment. If we have any doubt about the equipment, that's when we retire it. When in doubt, throw it out. And finally, make sure that you are documenting your inspections. If you haven't documented it, it hasn't happened. Let's start with personal protective equipment.
Also known as PPE.
The first thing up is our hard hats or helmets. We want to make sure, if you're in the States, that they are Z89.1 rated. If you're working around utilities, make sure to look for Class E. Don't assume just because it doesn't have vents that it's going to be a Class E. So the first thing that I like to do whenever I do a gear inspection is I like to check the shelf life. So our plastics generally are going to have a 5 to 10 year shelf life, but definitely check with the manufacturer to confirm. So starting off, let me hand you this little helmet here. We want to make sure that the shell is feeling the way we want to. So if you know what it feels like new, you should know what a good helmet shell feels like. If it's been doused in, say, bug spray, sunscreen, or a chemical, you're going to feel that kind of dimpling that might happen. And then after that, we're going to do a little squeeze test. We're going to check the integrity. And not only am I feeling, I'm using my senses feeling, but I'm also listening. I'm listening to how that sound is, just squeeze maybe an inch, and I'm also looking. So I'm looking for any gaping of cracks. So we want to look for crazing. So when plastic gets deformed, you can see that sort of spider veining or the white forms that are created around plastic when they get deformed. Once we're good with the shell, let's move on into the inside. So Warren, there you've got a nice suspension system. I've got the foam liner. So with the foam, I'm going to give it a nice little wiggle to make sure it's not moving and give it a little visual inspection, make sure we're good there. On yours with the suspension, I want to make sure that my points are all intact. They're where they're supposed to be. There is stitching along here. I want to check the integrity of the stitching as well as the integrity of the straps themselves. And then finally, we want to check that the buckle is working. So we're going to do a function test of our buckle. We're going to put it in there and give it a nice little pull and make sure it works. And once it's past that, then we're good with our helmets and we can move on to our eye protection.
Now there is a plethora of eye protection out there, of all different shapes and sizes and colors. What is important in our industry is that we have it rated at Z87.1 or greater. And that is for penetration protection for our eyes in and of themselves. Eyeglasses are not designed to keep all material and particles out of your eye, just the large particles that actually could damage your eye. So your fit needs to matter. Wherever you are in the world and the climate you're in, you have clear glasses, which are great for low light or dark situations. You might have tinted if it's for high light. Low light situations, yellow as well. And then my personal favorite, high humidity. Here in some areas of the US, I like the mesh. Now the downside of the mesh is they do not protect your eyes from any vapor and or liquid or chemical. So you want to make sure that they're appropriate for the task that you are doing. Also, if you have prescription lenses, one of the things that your prescription eyewear is going to have for our industry is side shields. If they do not wrap around, your glasses don't wrap around to give you that protection. And or there are some manufacturers out there that may have face shields for the hard hat. Now your face shield, it depends. It needs to be rated specifically for Z87.1. Some face shields just protect your face from large particles and sawdust. They are not a replacement for your safety glasses or your eye protection. After we've picked out the eye protection, now we're going to go to hearing protection. Again, lots of choices and options out there. Find one that is comfortable and works for you. All of your hearing protection is going to have a decibel rating, and that decibel rating needs to be appropriate for whatever power equipment and the noise level that you're using. Some of it will clip around the neck, some are foam that actually roll up and go into your ears, and or some of the most strongest protection here are the ear muffs that can actually clip onto the hard hat themselves. Now, most of these foam is just a visual check to make sure that they still have a shape. that they're not dirty and partially destroyed. A lot of things are replaceable this way. As far as the muffs go, your easiest way to do that is to pop them actually off the hard hat, stick them together. If you compress them, they should not fall apart. That means you have a good seal all the way around, and they'll seal around your ears as well. After our PPE for our head and face, now we're going to move to chainsaw protection specific.
Now, anytime that we are operating a chainsaw, whether that's in a tree or on the ground, make sure you check with your local regulations. We want to make sure we're wearing chainsaw protection on our legs. So we have a couple options. We've got chaps here, these buckle around the ankles, or we have pants like what Warren is wearing. Most importantly, we want to make sure that we have that visible label on there. That label is going to be marking what standard it meets. So it should have a UL or CE rating, or you might see ASTM. So confirm that you have that. If at any point it's not visible, it's probably time to replace your chaps. Now let's talk about the fit. So the most important thing is that everything is fitting properly, or else it's not going to function. So with the buckles, we want to make sure that all of the buckles are functioning. We'll do that function test. And at any point when you're wearing chaps, they all need to be buckled. In addition, the length is very important. They need to come up over your boots, over your ankles. We don't want to have chap capris. We want to have full length pants. For retirement, we want to check for any oil stains, any cuts, picks. If you've actually used the chainsaw and they've cut the pants, then it's time to retire them. Any burns as well. Anything that is going to compromise the integrity of the materials inside means it's time for them to be retired. Warren, anything else to add?
No. At the end of the day, make sure your label is still legible, and make sure your PPE makes you look good. As far as rope goes, we don't have regulations for rope until we give it a job, all right? So are we going to be using it for personal support and climbing, or are we going to be using it for rigging applications? That being the case, in the US, it's currently 5,400 pounds. Most of the rest of the world, it's 5,000 pounds, which is 23 kilonewtons or greater. So the characteristics of a rope, they do matter. 3-strand rope is one of our first ropes, been around for a very long time. Again, these are all plastics in some way, shape, or form. The 3 strands, very durable, but it is very stiff as well. Rope in and of itself has many positives and negatives depending on its construction. The next type of rope is a 12-strand. Now this is 12 strands of braided rope, but there's no core. It's actually a hollow braid. And this is one type of 12-strand, this is another. We have to keep in mind that there are a plethora, a lot of different types of colors and configurations and all that kind of stuff with our rope products. We have to know the construction of them, because that's going to matter when we try to apply them to a work position. This is a 16-strand rope. This rope is very popular for a climbing line. As far as the rope goes, all the strength is in the cover itself. The core is there just to keep its shape and to keep it from compressing down and folding. Then we also have a 24-strand. This is a hybrid rope. This is actually a version of a double braid, which means there is a braided rope in a braided rope. That being the case, this rope is much stronger than these others of the same size and has its own characteristics. Because of the 24 strands, you're going to have more surface area going over your branch unions and other such tools. So while this rope does very well in natural branch union rigging or climbing, this one is going to prefer some kind of tool to mitigate that kind of friction. Popular for climbing lines are a lot of different kind of colors. Here's another 24-strand double braid rope, much more common for rigging purposes, a little less colorful, helps designate it for rigging versus the climbing. And then we also have Kermantle kind of ropes, which basically is the cover is all about abrasion and protection to the core that is doing most of the load bearing, or all the load bearing, excuse me. So in a double braid, our cover might have about 60% of the strength, 40% in the core. Kermantle, all the strength is in the core. And then if we go to the 12-strand, has no core, so all the strength is on the outside. When we put it into use and apply it into the field, that's going to matter. Now, how we terminate these rope products to our actual hardware or to our harnesses, we can either tie a knot or we can use splices. Now, this particular splice is a hand splice. Hand means it's done not with a machine, but by actual humans' hands. And for every type of rope and the construction, there's a specific splice for that, which means hand splicing is a learned trait, and you have to be very skilled or certified in order to do it. Here, these are machine stitch splices, meaning that the machine is doing that. This machine stitching is a specific pattern for the rope construction. It cannot be duplicated in your basement. So again, it has to be done by a machine or manufacturer. When we're talking about splices, some of them are coming, most of them when they come out of the manufacturer, they are covered in some way, shape, or form by a plastic or a coating and also have a tag from that manufacturer. If that tag comes off, depending on where you're using it and what application you're using that rope, that could be a problem. In crane use, as far as our slings go, everything has to have a tag. As far as climbing, depending on where you are, if the tag is gone, that's not necessarily a retirement moment. Also, the plastic is there just to protect the stitching and the splice itself. If the plastic comes off, that's not a terrible thing, but now the stitching and the splice is exposed to possible damage and wear, and that becomes an issue. All right? Now let's start talking about our retirement criteria.
So with the textiles, this is going to be kind of like the plastics that we dealt with the helmet. We're looking at a roughly 10-year lifespan, but that depends on where. It could be a lot sooner depending on what the product is, such as a rope bridge is definitely not going to last 10 years. So make sure you check out in your manufacturer's guidelines in the user manual and look at what their criteria is for their product. With the actual inspection point, I'm going to run through this rope, which is in very good condition, but just the process. I am running the whole rope through my hands, and I generally like to start where I know that there's going to be the most wear. So if I have a splice on my rope, I generally know that that's the end that I'm using, and that's going to be what is experiencing the most wear. So I'm running my hands through the rope. So this hand is doing the feeling, this one is doing the guiding, and in that process I am looking at the rope, I'm giving it a visual inspection, I'm feeling it with this hand, I'm holding onto it so I can feel changes in the diameter, I can feel the caterpillaring, which I'll show you in a second, but I can feel a lot. And then I'm also smelling it, because if this rope has sat in fuel, I will definitely be able to smell it as I go through the inspection. It'll be on my hands. We'll also be able to see how much dirt comes off on our hands when we do this. So I'll run through the full length of the rope when I do that inspection. And what I'm looking for is something like this. This is caterpillaring. This is excessive wear on the product. I'm also looking for, say, okay, for this adjustable friction saver, I need to make sure that I move anything that's on there to expose potential problems. So we've got a cut right here, and it looks a little bit burnt too. I don't know exactly what happened there, but that's definitely going to be retirement. We're also looking for excessive memory. So this hitch cord clearly sat in one position for a long time, same with that I-splice, that split tail. This is going to be a retirement criteria. This is going to be out just because of the memory. And then finally, the glazing. So if there is too much friction, again, this is plastic. If you move too quickly on a rope, you're going to get glazing, which is the melting of the plastic, and it makes it so the fibers can't work independently. So it's going to be that kind of glossy, solid. When it re-solidifies, it'll be sort of this hard spot in there. And that is also going to go over our retirement criteria. Always check out what the manufacturer indicates. A lot of them have on their websites very specific things to look for to make sure that you are ready to retire it. Same with any other plastics, textiles, we've got retirement criteria. Again, here with this nylon loop runner, we just have some cuts on here and we can see it's compromised all the way across. So we want to make sure that that is retired as well. Rope is cheap. There's no reason to save it. If at some point I'm asking Warren here, hey, is this heaving a little bit too much? If I'm asking that question, it's time to just retire it. Just get a new one, because your life is not worth saving this piece of plastic.
In general, we have a rule about 10%. If 10% of this rope is damaged within any 1-inch section, just replace it. Again, rope is cheap. If I have a 16-strand rope and I have more than one full pick cut, and I get into 2, that's over 10% of the 16 strands, retire the rope. And again, this is in a 1-inch section. If I have 2% damaged here, 2 here, 2 here, that's not a big deal, but too much damage in one spot is a structural flaw, and it's an automatic retirement.
Let's talk about washing our ropes. So if you're really wanting to wash it, you can do it in Woolite, Johnson & Johnson's baby shampoo, or once again, confirm with the manufacturer what it is that they've approved with their product. Make sure you thoroughly dry it before you put it away. Not only is it damaging to the product if you put it away wet, you're definitely going to smell it when you pull it out the next time. Once we're on to storing it, we're always going to want to store our ropes, our textiles, anything away from sharp objects. So keep your scabbards on your handsaws and your chainsaws. Keep it away from the fuel. Anything that is going to damage or soak into your ropes. We have 2 choices. We can either coil the rope, which is nice if you have a space to hang it, or even better, you can put it into a bag. I like to leave it a little bit open so it can breathe and not get too musty in there, but this also helps to keep it away from sharp objects. It's nicer for towing it around. That's my preference.
Absolutely.
Let's talk about hardware now. We have tons of hardware in our climbing systems, as well as in other functions of our job. It's really essential for us as professionals to understand the different standards that they need to meet. Just because they're made of the same material doesn't mean that they're going to have to meet the same standard. So let's start off with, for instance, the snaps. We've got snaps and carabiners. And depending on what country you're in, then you're going to have different standards that you need to meet. But we need to make sure that we're at that 5,000 pound or 23 kN whenever we're using those. They also need to have, for snaps, double action. For carabiners, they need to have a triple action, double locking, and auto locking. They need to be able to close on their own. So make sure you understand what your regulations are in your area so you know what standard it needs to meet. You can also find out whenever you purchase your equipment or even on manufacturers' websites, you'll see in the user manual, it'll let you know what standard it's been tested to, and you can ensure that it's actually going to meet the need of how you're planning on using the product. And you can ensure that how you're planning on using it is meeting what it's been tested to. So we want to match form to function. So with the snaps, we're going to be using this generally on our lanyard or somewhere where we are not moving around in the tree. It's mostly work positioning. And then for the carabiners, this is going to be attached as a connecting link in our climbing system or a lot of other functions. Depending on how you're planning on using it, there are different features. So if I'm using it in a life support configuration, I need to make sure that I'm meeting that triple action double locking feature because that's what meets the standard. But we do have other carabiners out here. This one does not have a locking mechanism. There are screw gates. None of these can we use for our life support component, but as accessories, we can have them around. Just be very careful to make sure that you don't accidentally put it into play in your actual climbing and life support function.
The other piece of hardware that's commonly used is blocks and or pulleys, and they both come in wide varieties. Pulleys generally are considered anything that needs a connecting link in order to attach it to some other object, whether it's a harness and or a piece of textile, all right? Here we have a mini pulley, movable cheek plates. Here we have a much larger pulley, usually used for rigging in some way, shape, or form. Again, movable cheek plates. And you would not want to perform or put any kind of textile or rope product directly to here without a connecting link. So that's a pulleys. Blocks are usually considered heavier duty, built to take more abuse. I could put a rope product or a piece of textile directly to this. They're a little stronger. The cheek plates are in a fixed position. And again, they come in a wide variety of shapes and sizes.
Now let's start the inspection process. So when it comes to hardware, how old is too old? Well, usually the manufacturers will say that hardware is good for as long as you keep it in service, so long as it is still functioning and meets all of the retirement criteria. If you take good care of your hardware, you could have it for a really long time. Now, if we go into the actual nuances of them, so much like the other equipment, when we know we have very specific wear points, that is where we can start with our attention, is anywhere that you know is regularly getting high friction areas or connecting links where you know that that is what is likely causing the most damage, that's where you can start. Let's go with the carabiner just because it's simple, and I'm going to take this one right here, and I like to start with a function test. And when I'm doing my function test, I am looking and I'm also listening. But we can't depend on just the listening because sometimes it'll sound right, but it hasn't quite locked properly. So when I'm doing my function test, and maybe my shirt will be a good background here. So I'm going to start off with it fully open and make sure that it closes and you can see that the gate has fully turned and there is no delay in it. And then I will do a little half shut, and make sure once again I heard it lock, and I also look to see that the gate is properly shut and locked. And then the last one, I'm just going to turn the gate. I'm not giving it any momentum. I want to make sure there's still no delay and let it go. And once again, it has locked and it's doing exactly as it should. Now, if you have a carabiner that is a little bit sticky, as this one that is retired does, we'll see that there is a little bit of a delay. It's a little bit slow. But we can see that with these, that when you start to get a little bit of age behind them, they'll slow down in their action. In addition, we're looking for cracks, corrosion. Here we've got some rust starting to form here on this ring and ring. Okay?
You know, our connecting links are either aluminum or steel. Rust typically builds up on steel as it ages and exposure to weather, where aluminum, it gets pitted and actually starts to corrode and decay in that way. Not necessarily rust, but very similar because of aluminum. Also, we're looking for deformity and we're looking for things to stop lining up the way they should. In one case, when we're talking about pulleys, I want the cheek plates to line up exactly as they would. When they start to have too much of a gap, then I know that I have wear here at the pin area, and I'll pick up this one to show you. That has too much of a gap, there's too much play in the cheek plates, and that pin has started to worn out. And this is going to happen over time, and it's going to be up to you to keep track of that piece of material so you make the call as far as when it has had and seen the last of its service life.
Hardware is definitely one of those that is very helpful to know what the product should look like new. If you don't know that with this hitch climber that these plates should be straight, you might think that it should be warped like this. But in fact, this is a severely damaged pulley from being used incorrectly. It was not matched from how it was tested to how it was actually used in the field. So that's why we have this problem here. So it's good to know what your product should look like new when you're inspecting it so you can confirm that there was a change.
And we're going to talk about deformity. Deformity is how much visual wear has taken place from the newness to now. Our ropes and our textiles have an abrasion when they come in contact to aluminum and steel. Aluminum, being a softer metal, is going to degrade and be worn out far faster than the steel will. When we get to deformity, if it's for any kind of personal support, if I see more than 10% of wear on this piece of aluminum, I'm going to retire it. And for me, if I can actually see the deformity, then that's too much. Now, if we talk about the color of a unit, that's not necessarily deformity. The iodized coating on our snaps and our carabiners starts out good, but actually we've only worn away the paint. If we're not actually deforming any parts of the piece of hardware, then it's just seen some age. It's probably still structurally sound. But if it fails that visual and or whether or not we can actually feel to see if there's been deformity, that's time for retirement as well. Not only deformity, but anything that has a shiv that's turnable, we want to inspect that and make sure it doesn't have any nicks or abrasions, because if a rope product or any kind of soft textile goes in there, that could be damaged by that burr and then we either have to maintenance the burr and sand it back down a little bit with emery cloth, or we have to replace that particular item. We also have what we'll call hybrid units. These are now mechanical hitches. We're getting into mechanicals to replace a lot of our textile on textile contacts. Reasons for that are being more consistent friction, but this is something that has a lot of moving parts. And whenever you get into something that has multiple moving parts, you have to take the time to inspect each and every movable part on there. And I can have a shiv point here, but it also has a pin. I have to check all of my pins, all of my connecting links to make sure I don't have any kinds of crack or damage in any or all of those. And then make sure it's still in alignment, hasn't been side across loaded in any way, shape, or form. And regardless what kind of mechanical unit I am using, I have to do that with all of them. And for myself, I do these visual checks at least every time I use it, every day. And I use an even more comprehensive checklist quarterly. And then I keep my records for myself, an annual inspection on all of my stuff. Believe it or not, sometimes time flies and we forget how old something is. And if we don't actually take the time to put it down in paper that I've inspected this, and then all of a sudden I pull this out and I was like, it's actually been 8, 10 years in the field. That's something I want to keep in the back of my head. Because I might want to put it back to a newer unit to see, do I really know what the wear is on this? Or you can always go back to your owner's manual and all the information you need to know about that particular connecting link or that tool is going to be there. Also, if you've lost this, which can happen, you can go online and you can download it from the manufacturer's websites as well. So.
These hybrid products are getting very complicated and there are a lot of components to them, so it might seem a little bit daunting on how to do that inspection. But once again, when you look at that user manual or go online, a good manufacturer is going to have very specific inspection criteria to tell you what components you should be looking for and looking for very specific possible safety recalls or notices if the manufacturer is receiving notification to say, hey, this particular part of the product tends to wear a bit more quickly, take a look at it. Make sure you get on their listserv or make sure you somehow have some schedule for checking that your product hasn't been recalled or that the manufacturer hasn't sent out some sort of a notification. But they are more nuanced, there's more complexity to it, but the manufacturers have outlined some very specific criteria for us, so don't be intimidated by it.
And also, just because that particular tool might not be used for rigging and or personal support, even if it's used in conjunction with your system, it should be checked. Some of our ascenders units are not necessarily holding us in the tree or on the rope, but still, if this were to fail on me while I'm ascending, that will be a problem. I need to make sure that it functions the way it's supposed to, the way the manufacturer designed it. Many times we don't include our spikes in part of our climbing gear and our inspection. We take it for granted, but to actually check the screws and all the other mounts, sometimes we have to move the pads, take them off. This needs to be inspected just like all the rest of our hardware and all the rest of our textile products, and they should all function exactly the way the manufacturer built them to function, and they should do it every time.
Now, what kind of maintenance can you actually do out in the field? So that's going to depend on what the manufacturer specifies, but there are some options that we have. So say it's a sticky carabiner, you do have available some lubricants depending on what the manufacturer is okay with, generally a 3-to-1, or duck oil might be okay, but again, make sure to keep up to date because these things do change. Additionally, if you have, say, a burr on your pulley, anything that is running on rope, that could be on your hub. Once again, any of our hardware that is rubbing on rope, we can get some emery cloth and smooth that out until it's not going to potentially damage your rope when it's being used.
Washing in general, the same with our rope textiles. I use the same thing on my hardware. I use a mild detergent, either Woolite or some kind of baby shampoo, and I'll try to get it in all the nooks and crannies. Sometimes just the washing, and I wash my stuff fairly commonly, keeps the maintenance of having to lubricate it down and stuff because just dirt in and of itself is abrasive and can ruin the function. So just consistently washing your equipment with mild detergent is just going to extend its lifespan in general.
And finally, the retirement. How do we properly retire any of this? Well, we want to make sure that nobody is going to pull this out of the trash and use it. So if you can hammer it or do something to completely damage the equipment so no one is using it later, then that is a good possibility. If you are in the field and you are somebody who is training possibly, you can see here we have these all marked with some tags that say do not use. That's because we save our retired gear for training purposes, but again, it's really essential that you make it super visible for people that it doesn't accidentally go back into service. We want to make sure that our retired gear stays retired.
And like we mentioned before, climbing and rigging gear are same but slightly different. If I'm going to climb with something, I only climb with it. If the climbing gear I'm using needs to be retired and I don't want to use it anymore, but I want to put it in my rigging, I have to make sure that it looks exactly or totally different than my climbing gear, or just take it out of the field, out of service in general. I've got a special bag for all my retired stuff, so I use it as examples later, but lockout, tag out works just as well. And now we're going to talk about harnesses. You know, the past couple of decades, they've come a long way from where we started with this bare bones, nothing but function harness, to the harnesses we have available to us now that are far more comfortable and are far, far better in their technology and their fit and function. That opens us up to simple sometimes is easy, but I'm not going backwards. But let's talk about what we should be looking at and the specific areas that we need to pay attention to with our current arborist harnesses.
So first of all, as always, we want to start with the label. So all of the products that we have here have a very specific place that they put the age of the product. So it is generally 5 to 10 years, like we talked about with our other textiles and plastics. So right there, Warren, you've got your age right there in the back of my harness. I've got a label that is embedded in the belt. So that tells me what the age is, so I know how old my harness is. And then right there, the Petzl one has that nice label that's tucked away so you can find it. So we want to make sure we know how old the harness is, because as Warren mentioned earlier, it's really easy to lose track of how long you've been using it. So once we've gathered up how old it is, we can also confirm that it meets a standard. If we're checking somebody else's harness, if we're seeing it for the first time, we can make sure that it's meeting those industry standards that we need to meet. The best part about inspecting the harness now is you've basically graduated. Congratulations, you now know how to inspect plastics, textiles, and hardware. We're putting it all together now, so now the goal is just to be systematic and making sure that we don't miss anything. So Warren's going to start us off with our biggest wear points, where we're putting the most wear and tear on our harnesses.
Now, wear points are the points that are going to take the most friction, the most use, the most wear every time we're out climbing a tree and using our equipment. The best information about these wear points is going to be the manufacturer. And honestly, there's so many adjustable parts on these new harnesses, I would really suggest you actually read your manufacturer's recommendations when you get your harness, just so you know where all the adjustable parts are. And a lot of these harnesses have specific areas and parts of them that are replaceable. Our rope bridges are one of the parts of this harnesses that is replaceable. We have to keep in mind, if this harness is made by a specific manufacturer, when we replace a part on it, we need to replace it with the same part made by the same manufacturer for this harness. I don't want to put a different manufacturer's leg straps and or rope bridge on this harness. And some harnesses not only have specific rope bridges and lengths, but they also have specific knots that had to be tied in their harness. Again, manufacturer specifications. It was tested with this configuration. When you replace any part of it, it has to be the exact same configuration that it was originally set up with. Another reason to always keep these, manufacturers give very good details about the exact knot, exactly how it should be installed and replaced. These things are tested for a reason, for your safety. If we alter them in any way, shape, or form or change their configuration, we've basically taken that out of compliance and we don't know what's going to happen, and neither does the manufacturer, which is why they want you to replace their rope bridge with their rope bridge product for that particular saddle. Whether it's year, make, style, replace it with the exact same rope that came away from it.
In addition to the bridge, we have other suspension points. In the case of this harness, they've indicated it with the green hardware. So this is the tree motion. So I know that these points are places that I could suspend from. And because of that, I want to make sure that I'm inspecting them for any additional wear. So this is going to be a connecting link, and it could potentially start to get worn down. Not to be confused with the red parts on this harness, which are not for life support. So again, that goes back to read your user manual, know how the parts are supposed to be used, so that way you're using it correctly. So we've gone through the kind of life support components of where you're potentially going to be suspended from, but then we want to get into the comfort points, and comfort's changed a lot in our harnesses. We've got a lot of nice lumbar support. We've got additional features. So it's all going to be personal preference with what you've ended up picking, but you're going to check to make sure that everything is just still in place to where it was originally when you bought it new. And we have some leather components. We have more of our foam and some other textiles around, and we want to just give it a visual inspection, check that it's all still in place, nothing has gotten too worn down. There might be some parts that really rub, and again, depending on the manufacturer, there are replaceable parts. So you could replace a leg loop if that's approved by that particular manufacturer. So just check. If it's not comfortable, you're not going to be comfortable while you're working in the tree. So as it's not even frivolous. As much as we want to be comfortable, we're only going to be comfortable if our harness is in good shape, and part of that is the inspection of the belt. Once we've moved on to that, we can move to any buckles that we have. So this particular harness, I've got some metal components joining the webbing around, but more specifically, let's get to these functional buckles on this Petzl harness. So we can do a function test, just like we did with the carabiners and with the snaps. We want to make sure that it's functioning the way that it should. So if Warren were only to press down on one of those buttons, it should still hold in place, but then it should move freely when he has moved both of them. So again, we want to make sure that our leg loops aren't going to come undone while we're doing work. So function tests on the buckles is really essential, but make sure you know your harness to know which function tests need to occur.
The other thing I want to just point out, depending on your manufacturer, some of them have rings instead of fixed attachment points, and those rings may have a section of them that is removable in order to replace the bridges. This removable section must be maintained as well. There is a certain amount of torque you're supposed to be putting into this. It is specified in the manufacturer's instructions, and when you replace a bridge, you need to put it back and torque it down to that particular kilonewton rating and then protect it. But again, we need to inspect those like we would anything else. It's a little bit different than the saddles of old. Fixed D-rings were just simply fixed D-rings, right? So now we have to check all the parts. Some of them are more complicated than they used to be. As far as the stitching goes, we've checked the visual, our textiles. Now we are really concerned in the stitching that is life support. There are a lot of extra on these harnesses now, and a lot of that is simply for extra equipment, gear. Some of it's just for looks. If I lose a little piping or stitching that's along the top of this back pad, not necessarily a big deal. But if I have damage to a stitching, the double tack and or the X stitching that actually is keeping me in this harness in the tree, that's a problem, and any kind of damage to that kind of stitching is an automatic retire. I don't want this to just be a little bit damaged. I don't want it damaged at all. So anytime anything is for life support and it is damaged, it's an out of service. But if I happen to have one of these, you know, this is just a strap to keep my leg straps in place. If it breaks, am I going to fall or even move around in the tree very much? No. So that's not really life threatening. And again, depending on your harness, you might only have 4 or 5 places to look. Some of these harnesses, you have multiple areas that you have to check all this webbing and the stitching.
So once again, check your harness regularly. This is your life right here. Check with your user manual to make sure you know what components there are, especially those key wear points, and know those replaceable parts. It's really important. This is our number one right
Absolutely
here, right?
is. And as far as maintenance goes and the washing thereof it, you should always wash your gear. Dirt causes abrasion, causes wear. So again, Woolite, mild detergent in some way, shape, or form, air dry, no heat, no dryers in any way, shape, or form. The cleaner your stuff is, the longer it's going to last for you, and the less overall maintenance you're going to have to put into it.
Configuration, how we're using the equipment, is key to how it's going to function. A lot of the time, premature wear of our equipment can be due to the fact that we've misconfigured it. Again, the manufacturers have specified how equipment should be used and what it's compatible with as well. We didn't mention that specifically, but certain equipment is only compatible with other kinds of equipment, and Warren's going to go into detail with that. But make sure whatever you're doing, you're using your equipment the way it has been tested and the way it is intended. So Warren, could you go through with us some key examples of misconfiguration you've seen in the field?
As arborists, we are totally shameless about what other tools that we can take from other industries and make our job either safer, easier, what have you. But when we take those tools, we must understand what they were designed to be used, and are we using them in the same way, or are we taking them outside of the manufacturer's specification range? As we have developed our systems, sometimes the old and the new don't necessarily play nice with each other, all right? One of the biggest things I see is traditionally a lot of snaps were used in our systems, and now we're going to more and more of carabiner use. And the carabiners interface a lot better with a lot of the other tools and such that we're borrowing from other industries. But if we mix a carabiner and a snap, do they play well together? Now, one of the rules of thumb is we do not chain connecting links together. I do not want to put a carabiner to a carabiner or a snap to a carabiner simply because you can only rotate so far before you're going to stress the gate of either the snap or the carabiner, and failure will be the result. Also, if I were to put both of these on a bridge, not like a D-ring, but because the bridge on these new harnesses, they can coincide and be together, what can happen is if I don't have them totally loaded the same all the way, the snap can easily go through the carabiner depending on the carabiner size, and then again I can twist and I can cross-load or misload the carabiner and or the snap and cause failure. So if I'm going to use snaps, I should use two snaps together. If I'm going to use carabiners, I should go ahead and mate the two carabiners on the bridge. And that way we don't have any cross-loading in any way, shape, or form. Also, we talked about not chaining these together. I need something that is going to spin. Usually it's a textile or a rope product. Now we even have swivels that can go between the two, and that way I am not going to improperly load my piece of equipment. The other thing that I have seen, and we have these wonderful bridges, and many times we can take a carabiner or a snap and go directly to the bridge, but some climbers want it even smoother than that. So what they seem to think is going to be a good idea is, I could take a pulley and I can put the pulley right on my bridge, and now I've got super smooth, no friction whatsoever. And that seems like a halfway decent idea until we go back and say, okay, what was this pulley really designed to do? Even though it's rated for personal support and its tensile strength, was it designed to be put into this application? And when we go back to manufacturer's recommendation, this was not designed for that. What's going to happen is because these cheek plates can move and a lot of stress is going to be put on the pin, as I start to twist and turn on this, I'm also going to be twisting and turning these cheek plates, and I'm going to get excessive wear and failure on this pin before it's time. So this was designed to be used in a straight up and down motion in coordination with a friction hitch and some carabiners on there. Straight up and down would not put wear on that pin, and thus it's going to have a long lifespan. If I want to put some kind of pulley or something on this bridge, I need something that has fixed sides so that I'm not stressing the bridge. So this is a type of pulley that could be used for that particular application, and or I could easily simply have just a couple of rings on a bridge. And you can put it that way. But again, you have to ask yourself, am I putting together components that are actually going to work well with each other and not cause premature wear, failure, and any kind of damage? We also have many different mechanical hitches. Again, am I using these properly? Read the manufacturer's specifications. Many of these mechanical hitches have very specific rope construction and/or diameters that they were tested for. If you put another rope in there that is not recommended by the manufacturer, you can have some problems, and we don't want problems. We've got enough of those, again. So, read the recommendations. If you don't have the printed copy that came with the unit, look on the website, download the information. Make sure that you're putting the proper rope that this tool was tested on using, all right? When we talk about systems, a lot of times we have things set together. Here, this is my lanyard. This is my work positioning system. Now, I've put together a lot of separate components on here. I need to take the time to make sure that all of my components work well together, and that not only are they functional, but they're not going to cause damage to each other. This is a friction hitch on a carabiner in line on the hip, and/or if I was climbing with it, this is basically a mini climbing system that I'm using for my positioning. Also, I have a separate device here that I can use to create a false tie-in point anywhere on my lanyard, and that way, when I've loaded that, I load my carabiner on its spine, and I am not wrapping this around. Can I use your arm? Mm-hmm. If this was a branch and I didn't do this, and I just put it on the rope itself, this would not be the proper way to load a carabiner. I could cause failure if I put my weight into this. So again, we want to make sure that when we put systems together, they support the manufacturer recommendations and do not cause an issue of failure. Here's another example of a system. Here's a zigzag. And the zigzag, along with the chicane and the stationary rope system. Again, Petzl has made all of these components specific to each other. This is a rope wrench with a tether. It does very similar to the chicane, but it was not designed by Petzl. Petzl did not test this device with its zigzag. So if I were to put this on top of it, would seem to be feasible. This is still not a configuration that is approved by the manufacturer. You shouldn't do it, all right? That's all there is to it. Again, all components of a system. This is a bailout unit for a bucket. I want to check and inspect every part of the component and make sure that everything is working the way it should and none of the components are worn out or may have issues. One of the things you might see not only in this bailout unit, but also on this carabiner here, the one drawback of a carabiner is because it has no captive eyes on most of them, that you can get a lot of movement that you might not want. So for example, if I were to use a separate carabiner besides the one I just had in, if I did not mind this carabiner as I was climbing around in the tree, there is a possibility that this could side load or misload in some way, shape, or form. This could cause a failure. So to have some part of the carabiner, whether it's a pin or a captive section in some way, shape, or form, so that I didn't get that kind of roll, that is a wonderful thing. One less thing I have to worry about while I'm moving around in the tree, because we've got a lot of other things to worry about. Again, let's go back to some of the traditional things that we still have. Here's a split tail. And we've talked about eye splices, but we need to get a little more specific about what type of eye splice. This is a large eye splice. And the reason why I would want this large eye splice is if I still had snaps in my systems. The advantage of the large eye splice is because I can put it through the captive eye there in the snap, then girth hitch it around the whole unit, and it's secure. If I have a small eye splice, only a carabiner is going to work in a small eye splice, whether it's a hand stitch or a machine stitch, all right? This configuration works great on a snap. It's kept in position. The rope or textile doesn't come in contact with any of the other parts of the snap. If I were to use a carabiner though, here's the example of what some people have done as far as the large eye, because it's not captive, this carabiner can move all over the place with this eye. So what they have come out with, they have something called a Blue Bandit rubberized band.
We've got
And that way, it makes that large eye small. But that rubber is only as durable as a couple of shots. It's eventually going to fail. If you tried to do that with a regular carabiner, you might have an issue. I use this one specifically. Every carabiner or certain carabiners have different shapes, right? This has a little more space at the bottom of it versus this carabiner here. If I tried to girth hitch this rope onto this carabiner, that particular girth hitch is rather fat for the carabiner. And if I move a little bit, it can actually push the gate up and take out one of the movements that it actually needs before I can open it. So this is not the best configuration to use with this type of product. You're going to make sure you're either using a snap or use something that captivates that section of the carabiner, or be very diligent about always replacing your Blue Bandit anytime it fails. Last but not least, again, our ascenders are not necessarily things that are holding us in the tree, but they become very specific. We can have ones that are for the left foot or the right foot. You can put a right-footed ascender on the other side. It might change the way it operates. It might change the way it works on your body. They're specific for a reason. Make sure whatever your product is, that you're using it the way the manufacturer designed to use it. And if you deviate from it, you're exposing yourself to possible failure, and it's just not worth it. Just use it the way it's supposed to, and everything is lovely. We can go to enjoying the tree work we love doing. Thank you for joining us. And remember, your user manual is a wealth of knowledge and information.
If you have an email address, make sure you submit that to manufacturers so you can get on their listservs and be notified whenever there are recalls or safety notices. Also, this is an ongoing process. You're not going to learn everything in one shot, so make sure you continue on your journey of learning about gear inspection.
And as always, follow your local, national, and regional rules and regulations. Again, we'd like to thank the ISA for setting up this video. We'd like to thank Husqvarna for sponsoring it.
Climb and work safely.
We look forward to seeing you at the next industry event.